I have here a Commodore 64 main board, revision number ku-14194hb, and today I'm testing a Commodore Factory PLA on an oscilloscope, and I'm using this Tektronix 243A digital oscilloscope, and I've actually got the computer running at the moment, and I'll switch it off and turn it on again. And I've got the divisions set to 1 volt here, so that's the zero line, so it's 1, 2, 3, say about 4.5 volts, and I've got the trigger level here running at 3.08 volts, and you can see over here I've got a trigger light just there. It's not set yet, and I've got the probes set to 10x. So the probe set to 10x, and the computer's running now. I'm just going to turn up the trigger level. You can see the trigger level there. I have the scope set to 20 megahertz there, and I've got the time sweep set at 100 nanoseconds, and the volts per division is 1. So I'm just turning up the trigger level now. I'll draw back so that you can see the trigger LED light come on when it does. So I'm just turning up the trigger light slowly. Okay, trigger light's just tweaking. I'm just turning it back, so at 3.44 volts on a Commodore Factory PLA. I'll just turn it up a little bit more. Okay, say 3.45 volts, the trigger comes on. I'll just turn it up a bit more. 3.45, yep, and it's triggering at that level. I've got the same Commodore 64 KU style board here. This time I've replaced the Commodore Factory PLA with a proprietary PLA called the Ultimate PLA, and we'll test that on the oscilloscope now. And I've got the oscilloscope set to the same settings as I had before. Got 20 megahertz. I've got smoothing on. The time base is 100 nanoseconds, and I've got the trigger voltage this time at 1.75 volts. The volts per division is 1 volt. I haven't switched the computer on yet. I'll do that now. Okay, so it's running, and it's actually triggered at 3.75. I'll just drop that a little bit. Okay, it comes off trigger at 3.69, and it's pretty stable there, and it's about 3.72 is the start of the triggering. I have the same Commodore main board ku-14194hb, and this time I'm running a one-time only ST branded 27c512 90B, and this one's not a genuine. This one is a knockoff, and it's got a production stamp saying it was made in China. Now we'll put it on the oscilloscope here. Now I've had to auto set the oscilloscope, and it's triggered now. The volts per division has been set to 200 millivolts. It's a 100 nanosecond sweep time, and the voltage variation is very low, as you can see here. It's triggering at 1.22 millivolts. If I scope out, to 1 volt. There's 1 volt per division there. The actual, it's a very flat line, and it doesn't really trigger much at all. I'll just do an auto trigger again. I'll set the bandwidth to 20 megahertz and get the same result. And you'll notice with this PLA, there's no capacitor on the CASRAM line there at all. It's just a straight EPROM plugged straight in. I have here the same KU style Commodore 64 motherboard. This time I'm using an original ST branded 27c512 90F1 UV erasable EPROM. I've got the little CASRAM capacitor on there, and I'm taking a reading off pin 13, which is ROM high, and I've got the oscilloscope set to 20 megahertz, and the trigger levels set at 4.59 volts at the moment, but it's not triggered as yet, and there's 1 volt per division. Now if I'll just draw back so you can see the trigger, and I'll turn the voltage up. Okay, and it triggers at about 4.75. I'll just drop that back. Comes off at 4.70, and about 4.72 it will just start to trigger. It's a very flat line there. Again, I have the Commodore 64 KU board, and this time I've got a UV erasable Texas Instruments 27c512 UV erasable EPROM, and this one's actually rated at 150 nanoseconds. Now the memory on this KU motherboard is rated at 200 nanoseconds. Sorry, I think I said the wrong thing. This chip is rated at 150 nanoseconds. So this is running pretty close to the speed of the board, and we'll see what sort of results we get on this oscilloscope. Now the computer's running, and again I've got 20 megahertz on the bandwidth, 1 volt divisions. That's the baseline there, so that's 1, 2, 3, 4 and a bit. Now the trigger level's at 4.44 volts and hasn't triggered just yet, and I'll just draw back so we can see the whole screen. Okay, I just saw a trigger there. I'll just turn that up a fraction. So at 4.5 volts we start to see some triggering. Now this EPROM was suggested to me that would work by a gentleman called Levo Man, and he did some tests on chips that are very similar, and he got his to work with really good results. So I thought I'd find some that were similar to his and test them on the oscilloscope, and these are the results, and they're very good. They are actually very good. Now this is running at 150 nanoseconds, this EPROM. I have here the same KU Commodore 64 motherboard. Now this one, I've got a very similar EPROM to the last one. This is a Texas Instruments 27c512 150 nanoseconds speed UV erasable EPROM. Now this one, you can see here, doesn't have the it doesn't have the CASRAM capacitor, the delay capacitor on there. And we'll have a look at the oscilloscope readings now, and you can see here it's triggered and you can see that dip lower, and this is triggering at 3.16. What I'll do is I'll drop that voltage down, the trigger voltage down, and we'll get it to flash on and off. So it's on the borderline now, and you can see it's 2.04. Now I've just changed it over to 20 megahertz. Sorry, 2.84, not 2.04 on the trigger voltage there. And I'll just drop that down a little bit more. So it's still triggering at 2.70. We get some random triggers just now, so you can see that every now and again there'll be a big dip, and that dip is where the problem, that's the glitch. Now what I'll do is I'll switch the chip out for the same chip but with the CASRAM capacitor installed, and we'll see what that effect has. Now I'm back again. I've got the KU style Commodore 64 motherboard. Now I've got this same chip that I tested before. Now this time though, the only difference is I've got a capacitor here, and that crosses that puts a delay on the CASRAM line. And we'll have a look at the oscilloscope readings. Now I haven't changed the settings from the last reading, and you can see it does trigger a little bit. I'll just turn the computer off and on again. Okay, no, we're still getting the same triggering. So this chip, which is a slight variation on the last EPROM that worked, is slightly different. Again, I've got the Commodore 64 KU style board, and this time I've got a Winbond W27c512 electrically erasable EPROM. You can see I've got the capacitor for the CASRAM delay installed, the scope set to 10x as in all the previous observations, and I've got the oscilloscope set up now, and I've got it triggering. It's triggering now randomly, and you can see the actual trigger voltage is 1.72, so it's actually triggering at 1.72 volts, which is pretty low. You can see the dip there, it's quite severe, and I've got it set to 20 megahertz bandwidth. I've got smoothing on, and I've got 200 nanoseconds for the sweep time and 1 volt divisions, and the little cross there is the 0 voltage line. I'll just adjust that up. So that's 0, so 1, 2, 3, 4, about just under 5 volts there, 4.577. And yeah, it's quite obvious that this Winbond electrically erasable chip is not very good at all as a PLA substitute for the Commodore 64, and it's just constantly triggered there, just constantly triggered. I'll try and get it out of trigger. There, it's flashing, triggering, See if it'll trigger again. Yep, it's triggering there, and that's at 1.47 volts, you can see there. And we'll just see if the light triggers again. And this is why there you go, it's triggering. This is why the Winbond EPROM based PLA substitute is not very good in my opinion.